Okay, so if you're using AI coding assistants, you know they can be absolutely amazing, but they've got one very, very expensive habit. Today, we're going to look at a tool called Code Review Graph that's built to fix that exact habit. The whole idea? Simple. Stop burning tokens. This quote from the project's own docs, man, it just hits the nail on the head. Every single time you ask for a code review or a refactor, your AI assistant basically starts from zero. It has to reread your entire code base just to figure out what's going on. I'm going to go out on a limb and say, yeah, it does. You make one tiny change in one little file, but you can almost feel the AI churning through thousands of lines of totally unrelated code, just racking up that token bill.
Let's actually put a name to this, right? Let's call it the AI amnesia problem. It's this constant state of forgetting and rereading for every single task. And it's not just inefficient and slow, it gets incredibly expensive, especially if you're working in big mono repos, where the token waste is just painful.
So what's the fix? What if we could flip that script?
Imagine giving your AI a permanent map of your codebase. Instead of making it reread the entire atlas every time it needs to find one street, it could just glance at the map it already has.
And that right there is exactly what Code Review Graph does. It acts like a cartographer for your code. It builds a local, persistent knowledge graph of your entire project. And this isn't just a simple list of files. We're talking a deep structural map of how every single piece connects to everything else. So, to pull off this sophisticated map making and then actually talk to the AI, the tool relies on two really powerful open source technologies working together. All right, so how does this magic trick actually work? Let's pop the hood for a second and see how this graph gets built and then put to use. So the first piece of this puzzle is a tool called TreeSitter. Think of it as a universal translator for code. It scans your source files and builds what's called an abstract syntax tree, or an AST. Basically, it creates a detailed blueprint that truly understands the functions, the classes, the imports, the structure of your code, not just the text. And it's super fast and supports a ton of languages. The second piece is MCP, the Model Context Protocol. And I absolutely love the analogy they used for this in their docs. MCP is like a USB-C port for AI. It's a universal, standard way for an AI assistant to plug into external tools. And in this case, that external tool is that awesome code graph we just built. So, with the map built and the connection made, we finally get to the tool's absolute superpower, calculating the blast radius of any change you make. So here's how it plays out in the real world. You change a file. The tool instantly consults its graph and traces every single connection that could possibly be affected, every color, every dependency, every test. This small, precise group of files is the blast radius, and that's the whole payoff. Only that minimal, relevant context gets sent to the AI. To put it another way, it's the difference between forcing your AI to read an entire library for a one-line change versus just handing it the exact chapter it needs to read. It's just smarter. Now, that all sounds fantastic in theory, right? But does it actually work? Does it hold up? Let's get to the data and see the real-world benchmarks. Here's the number you need to see, 8.2x. On average, across a whole range of open source projects, Code Review Graph cut down the number of tokens sent to the AI by a factor of 8.2. That is a massive efficiency gain. But what's really cool is when you look at the breakdown, you see these huge, huge savings on complex projects like Flask and Gin. But then look at Express.js. It's actually less than 1. And that's a really important detail. It tells you that for small, single-file changes, the overhead might not be worth it. The tool's real power is unlocked in those big, messy, multi-file projects. Okay, so the first question you're probably asking is, what about the risk? What if it misses something important? Well, the tool is designed to be safe with what's called 100% recall. In plain English, that means it never misses a file that is actually impacted. It does this by being a little conservative. It might flag a few extra files that might be affected just in case, rather than risk missing a broken dependency. That's a trade-off I think most of us would take. And all this efficiency doesn't slow down your workflow. Not at all. Once the initial graph is built, any updates are blazing fast. The docs say a project with nearly 3,000 files can re-index after a change in less than 2 seconds. That's just wild. So given everything we've seen, when should you actually reach for this tool? Is it the right fit for every single project? The answer's pretty clear. This tool is an absolute monster in complex environments. We're talking large monorepos, big multi-file refactors, or trying to understand deep dependency chains. That's where you get those huge token savings. On the flip side, if you're just fixing a typo in a single simple script, yeah, the setup is probably overkill.
And this brings us right back to that core message, doesn't it? It's a simple, powerful call to action that just perfectly sums up what this tool is all about.
And that really leaves us with one final thought. We all know our code isn't just a flat list of files. It's this interconnected system with a real structure. So the question is, are you giving your AI the tools it needs to actually see that structure, or are you just letting it get lost in the text, burning your tokens every step of the way?